Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. What the algorithm is trying to do is it's trying to guess your true ability level and gives you questions based on that level. So each question that you get is the GMAT's best guess of your true ability level. So the very first question, the GMAT doesn't know you yet, so its best guess is that you're somewhere in the middle. But if you're getting every question right, then by question number 6, you're going to get a very hard question because the GMAT is adjusting its opinion of you. Every question that you get, the GMAT is adjusting its opinion of you, not just based on what you did in the most recent question, but based on all of your performance to that point in the section. So if you're in question number 15, and let's say you get it right, question number 16 isn't chosen just based on the fact that you got number 15 right. It's based on how you did on all 15 questions up till now. And it takes into account a lot of stuff, right? It takes into account what is the actual difficulty level of each of those questions based on thousands and thousands of test takers before you, right? So it sees what percent of people got it right, what percent of people got it wrong, and it decides on a difficulty level based on that. And then it looks at how did you do on that question? Did you get it right or did you get it wrong? And that part is binary. So it doesn't take into account how long you spent on the question. It doesn't take into account which wrong answer you chose, if you chose the wrong answer. It doesn't care about any of that. It's just binary. Did you get it right or did you get it wrong? So it takes that into account plus the difficulty level of that question, and it looks at that for all of the questions you've done up to that point. And based on all of that, it makes its most educated guess on what your true ability level is, and then gives you a question that matches its guess, its best estimate of your ability level. Having said all that, some of the questions are going to be experimental questions and you don't know which. So the reason I tell you that is because if you get question number 20 and it's really easy, like 2 plus 2 equals question mark, don't panic, right? It doesn't mean that you're bombing the test. It's probably just an experimental question, and the difficulty level of that question isn't even known yet. That's why it's experimental. The whole point of an experimental question is they don't know how difficult it is, and they're trying to establish that by giving it as an experimental question to thousands of people. So don't panic just because you got an easy question. But also, don't blow 5 minutes on a really hard question for the same reason. It may be an experimental question. Well, there's also other reasons to not spend 5 minutes on a single question, but those are important things to keep in mind, and it can really mess you up psychologically. I remember it happened to me on an actual GMAT, where exactly that. I was in question number 20 or something like that, and I got something equivalent to 2 plus 2 equals question mark. And my first reaction was, oh my God, I don't know what's happening, right? Why am I getting such an easy question? Did I lose it? Like, did I lose the magic? And I can't do this anymore? But my second thought was, oh, it's probably just an experimental question. I still answered it correctly, just in case, right? But I didn't let it get to me. And so that's really important. Official books are questions that were on the actual GMAT. So they started out as experimental questions, and then they passed the experimental phase, which is a big deal, because a lot of questions go back to the lab after the experimental phase. I think that probably happens most often in critical reasoning, because in critical reasoning, you're, I think, going to see a lot of wrong answers that nobody picks. And if there's a wrong answer choice in critical reasoning, or really in any part of the GMAT, if there's an incorrect answer choice that nobody ever picks, then it's not a good wrong answer choice. They need every wrong answer choice to be tempting to a lot of people. So one of the things they're testing in an experimental question is, are enough people choosing every one of the 4 wrong answer choices? And if one of them isn't chosen enough, then it goes back to the lab and they come up with a better wrong answer choice. Just think about the amount of work and data, big data that goes into all of this. And I think that's why it's so hard for test prep companies to create real GMAT questions that mimic the real thing, because they don't have those kind of resources and access to test takers that they would need in order to build real questions. This is definitely a very challenging question. I think there are two different aspects of it that are very challenging, each of which is very challenging. The first one is interpreting the question. It's a very long and complicated word problem, and I think that it requires quite a bit of thought to figure out what it is that we're trying to solve for. And that in itself is very challenging. I think separately, once you've figured out what it is that you need to solve for, the actual solving part is also very challenging. So there's probably not that many people who can actually solve a question like this in under 2 minutes. It's probably one of the toughest word problems I've seen on the GMAT ever. But it is an official GMAT question, and so there has to be some way to kind of reason your way through this with minimal math or something that looks like minimal math. The difference in area of a square when you go from 10 squared to 11 squared, and that difference was 21, right? You gained 21 squared centimeters or whatever, versus when you lose a centimeter on each side, so instead of 10 squared it's 9 squared, and there you're losing only 19 squared centimeters. So you proved that going up will make a bigger difference. You'll get a larger delta than if you go by an equivalent amount down. But I do really like that you looked at some simple numbers to prove to yourself that, yep, going up will make a bigger difference than going down. What I did personally was I looked at 3 times 4. And I said, well, I could go up to 4 times 5, or I could get down to 2 times 3. And the gap here is 8, but the gap here is only 6. So very similar to what you did. So if you have some kind of rectangle, you think about the area of that rectangle, right? If you increase it by 1 for the width and also 1 for the length, you get all this extra area. So that's the delta if you're going up by 1 for the width and length. If you go down by 1 for the width and length, what's the area that you lose? You only lose this area. And you can see visually that the first area that I shaded is greater, because these parts are equal up to here. And all that's equal.
Okay. Yeah.
And then,
all right.
That's equal up all the way from left to there. But then you have this extra piece that makes a difference in the delta. So you can kind of see that visually. Yeah, so I think an important takeaway from this question is take the time in the front end to figure out exactly what it is that you need to solve for, so that then you only need to solve for what you need to solve for, versus doing a whole bunch of work and then realizing, oh, actually I only needed this part of the work. Probably you'd still be able to pick out the right answer even if you computed the wrong delta.
Yep.
But as usual, I don't actually care about this question. I just care about what we can learn from the question so we can solve other questions. And so for other questions, maybe it will be necessary to do that kind of thinking. And ultimately, the takeaway is do as much thinking as possible in the front end to make the back end as seamless as possible. So after all of that, I think we can now agree that what it is that we're trying to solve for is 200 plus 1 squared times 300 plus 1 minus 200 squared times 300. That's what the question is asking for. Now, if I had a calculator, I wouldn't have written it like this. If I had a calculator, I would have written 201 squared times 301 minus 200 times 300, minus 200 squared times 300. Why did I write it as 200 plus 1 and 300 plus 1? because I don't have a calculator. So I'm going to have to use some, I guess I would call it algebra, right? This would be 200 squared plus 2 times 200 times 1. Do you recognize that? That's the special product for the square of a sum. Plus 1 times 300 plus 1. And now if I FOIL this all out, I get 200 squared times 300, which works out perfectly with a minus 200 squared times 300. Those get canceled out. And what else do we have here? So we still have 200 squared times 1. That's the 200 squared and the 1. We also have 2 times 200 times 1 times 300. So that's 400 times 300. And what else do we have? We have that 400 times 1, and then we have also another 1 times 300 and 1 times 1. But I'm going to ignore those last few terms because looking at the answer choices, I don't really care about 400 or 300 or certainly a 1. All of those won't make a difference in the context of this question. After all, like Vivek was saying, they did have the word closest. So 200 squared, that's like 2 times 100 squared. So 2 squared is 4, 100 squared is 10,000, so that's 40,000. And 400 times 300, the 4 times 3 is 12. And we have another 4 zeros. So 40,000 plus 120,000 is 160,000. And this, I think, can be done in under 2 minutes. I just want to show, in case it's helpful to anyone, the two principles of algebra that we used there. So one was this, and the other thing I used there was if you have a plus b plus c times d plus e, the answer is, you just have to do all the pairs, right? So it's AD plus AE plus BD plus BE plus CD plus CE. I think it's really cool to practice not using a calculator, right? Because if you think about the math, the arithmetic that I did here in definitely under a minute, it's kind of incredible. It almost feels a bit like a magic trick, right? I did 201 squared times 301 minus 200 squared times 300, and I got a full answer. It was 160,701, although the 701 we kind of dropped there because we didn't need it, but if we needed it, we could have done it just as easily in well under a minute. And it's all thanks to this algebra. And we're using algebra instead of a calculator. And I talked last week about my dislike of long multiplication, and I think this is a great example of that, because if we try to use long multiplication to solve 201 times 201 times 301, I don't think we could do it in under a minute, or even in under 2 minutes. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below. And give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. One of the things I like to think about when I look at an official GMAT question is, how could they make it harder? And in this case, I think it's pretty easy to make this question much harder. I'll show you how after we solve this. I think the appropriate way to solve something like this is to start by rewriting the expression as a fraction. And in fact, I've said this to students many times in the past. Decimals are not good for the GMAT, and if a question gives me decimals and also the answer choices are in decimals, I would still most likely convert the decimals to fractions, do all of the work that I need to do, and then convert back to decimals at the end for the answer choices. That's how bad I find decimals are in the GMAT. So how do we translate the expression with all those decimals into a fraction? Well, we'd start by counting the number of digits to the right of the decimal point. And I'm seeing a total of, well, it's 4 and 3 and 5. So that's a total of 12. And then I say, okay, I've got 25 times 25 times 25 over this many factors of 10. Okay, so I literally counted the spaces to the rights of the decimal points to see how many factors of 10 are in the denominator of this number. If I were to write it as an integer on the numerator, that's how many factors of 10 I'd have in the denominator. And why is it factors of 10? Because we use a decimal system, which is base 10. So that's the reason for that. Okay, so that's the number. And now they're telling us that if you multiply that number by 10 to the power of k, you get an integer. And they're asking for the least possible value of k. Now the thing that we need to be careful about, although in this particular question it doesn't matter, but that's how they would make the question harder, is are there any common factors that could be reduced here? And the reason that in this case it doesn't matter is because we only have 5s in the top, and you can't reduce. You could have an infinite number of 5s, you still wouldn't be able to reduce any 10s from the denominator. Because in order to reduce a 10 from the denominator, you'd need a pair of 2 and 5. That's the prime box of 10, is 2 to the power of 1, 5 to the power of 1, 2 times 5. So in the absence of any 2's in the numerator, I don't need to worry about reducing any 10s, and I can go ahead and say that the smallest possible value of k is 12. I need k to be at least 12 in order to reduce all of the factors that we have here in the bottom. And maybe it would be better if I wrote it as a prime box. So we have 25 times 25 times 25, also known as 5 times 5 times 5 times 5 times 5 times 5, so 5 to the power of 6. And then the denominator we had 2 to the power of 12, 5 to the power of 12. What I did there is I broke down the 10 to the power of 12 into its prime factors. So it's 12 of each, 2 to the 12, 5 to the 12. And you can go ahead and reduce whatever you want to reduce. So it would look like that, I guess. Right? So 1 over 2 to the 12, 5 to the 6. But if all you're allowed to give this thing is factors of 10, and you want to get rid of the denominator entirely, you're going to need at least 12 factors of 10 in order to do so. You have to take care of 12 factors of 2, and the only tool that they're providing you with is factors of 10. So if the only tool you have is factors of 10, and you're trying to eliminate 12 2's, you're going to need 12 10's. Period. So how could they have made this question harder? They could have done this. That would have changed everything. Why don't I give you a minute to see if you can figure out what the right answer would be for this question? Do you think I'm right? Do you think a lot of people would still pick 12 if this were the question? Yeah, so in this case we would have, if we were to write this fraction as a prime box, we'd have 2 to the power of 4 coming from the 16, and 5 to the power of 4 coming from the 25 and the 25, and we still have that 10 to the power of 12 in the denominator, but the difference this time is that you can reduce some of the 10's in the denominator, right? You'd end up with 1 over 10 to the power of 8. And so how many factors of 10 would you need in order to get rid of the denominator? 8. So here's an interesting way to think about it, and I've found this metaphor to be really useful for decimal questions. Imagine that you're working at a factory and there are two conveyor belts that are bringing to you 2s and 5s. One conveyor belt just brings you 2s, factors of 2, and the other conveyor belt just brings you factors of 5. And the reason that those are the appropriate conveyor belts for this metaphor is because we have a decimal system, right? It's all base 10, and the primes of 10 are 2 and 5. So one conveyor belt is bringing you an unlimited number of 2s, and the other is bringing you an unlimited number of 5s. And you have a quota of 2s and 5s that you need to get. And that quota in this particular question was 12. You need 12 of each. Why? Because there was a 10 to the power of 12 in the denominator, and we needed to get rid of that denominator in order to get an integer. So we needed 12 2s and 12 5s in order to get rid of the 10 to the power of 12 in the denominator. Now in the case of the original question, we had 5 to the power of 6, so we had 6 5s. We picked up 6 5s from the conveyor belts, but we didn't have any 2s. And so how many 10s? So now I guess for this particular question, you'd have a third conveyor belt that gives you 10s. Or maybe there's another employee ahead of you in line that picks up a 2 and a 5 and packages them together and gives you a pack. So you're getting them in pairs now, right? And the reason in this case that it's pairs is because, remember, in this particular question, they said 10 to the power of k is the tool that you're allowed to use to turn that decimal monstrosity into an integer. So all you're getting is 10s. So that's why I'm saying there's a person in front of you at the factory who was pairing up a 2 and a 2 from here, 5 from here, put them together in a package, hands it to you. Next one, 2 and 5, puts them together, hands it to you. 2 and 5 together, hands it to you. So you're just getting 10s. How many, when would you be able to be done for the day and to go home to have dinner with your family? At what point can you leave? You already had 6 5s, but those 6 5s aren't really helpful to you because you need to take care of 12 10s. In the denominator, you're going to need 12 10s from the other person at the factory. But in the second question, my modified question, we had 4 5s and 4 2s. Those could already take care of 4 10s in the denominator, and then you'd only need 8 more 10s from the other person in the factory. So try to keep that visualization in your mind for the future when you're dealing with decimals. This idea of I have a conveyor belt of 2s and a conveyor belt of 5s, because 2s and 5s are the relevant or the interesting primes in the context of our number system. You're only able to get 10s in this question. They're not offering you 2s and 5s, they're only offering you some power of 10, and they're asking you, when can you go home? When have you had enough 10s to turn that thing into an integer? The way I'm visualizing it for the original question is you have at your disposal 6 of these. You've got 6 5s.
Right.
And the other person at the factory is only giving you 10s. How many 10s would you need to receive from that person? I mean, you could say to the other person, actually just give me 6 5s. And you could just say, well, I'll take 6 of these and 12 of these. That would be good. That would turn that into an integer. But that person isn't giving you 5s and 2s separately. He's giving you 10s. He's giving you them packaged up already. So if he's giving you them packaged up already, then it turns out that these 6 5s are useless. You're going to need 12 10s in order to reduce the 12 10s. If you were able to get 5s and 2s separately, that would be a different story. Then you'd say, okay, I only need 6 of these and I need 12 of these in order to turn that thing into an integer. But in this particular question, they're not allowing you that flexibility. They're saying, no, you have to take them as a package deal in 10s. And so that's what it is. And I think one of the important takeaways there is that there really there's not enough 5s in the universe to reduce a 10. Like it doesn't matter how many 5s you have. You're never going to be able to reduce a 10 unless you also have a 2. And if you've all seen in the past terminating decimal and non-terminating decimal. If you've seen that language on official GMAT questions, that's where I also find this metaphor of a factory with conveyor belts really useful. I did a whole hour on terminating versus non-terminating decimals for Manhattan Prep back in the day. You can enjoy an hour of me talking about that from a few years ago. And if you have follow-up questions on it, just let me know in the forum or here, and I can talk about it more next Saturday. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.